I'm set up. Welcome to another Zombie Ice video. Didn't think I would have to do this one either, but I keep proving myself wrong. I'm hoping to prove myself right in this one, however. And to start with, I wanted to bring up this nice video that shows how the sea level is going to rise and everything's going to be over flooded. And while that's running in the background cheerfully, I got the IPCC's chapter 9, which is sea level rise. I decided to look at where people are getting their information because, you know, things could be interpreted, extrapolated, etc. All right, so there was one thing that kind of struck me. Okay, so that's it. One thing struck me. It was like basically over time, the role of polar ice sheets is expected to be minor, but they contribute substantially to the total uncertainty. Antarctica is expected to contribute negatively to sea level due to increased snow accumulation associated with warming. So they're saying the warming is going to create more precipitation, which means snow, be more ice accumulation. So even though floating ice will not increase the level of the water, they're not even really saying that that's going to happen. But if you don't put that in your study, then nobody knows that it's there, right? In parts of Scandinavia, for instance, relative sea level is decreasing by as much as 1 meter per century. Yeah, that'll be explained later. Actually, I have Thomas Weissmuller on. That's I don't have him on. I just stole some of his video. He'll explain some of that actually. And here, it is highly likely that global mean sea level has been rising. I thought we were sure that this is a crisis, imminent crisis, but it's highly likely that it's happening. All right, so if you just pull out some paragraphs here that say, oh, you know, everything's gonna flood, and you leave this uncertainty stuff out, it's not a real complete report. I don't want to go into too much detail here. It's counter to a lot of what we are being told. So anyway, I'm going to start with the first video that I have, which is ways that they're going to fix the problem and make the world colder because we have this problem. So let's see what they're going to do.
The record number of fires burning across Brazil's Amazon rainforest has prompted renewed global outcry over climate change. And big spending. $5 million from Leonardo DiCaprio, £10 million from the UK. Meanwhile, Bill Gates is backing the first high-altitude experiment of one radical climate change solution, creating a massive chemical cloud that could cool the Earth. It's called solar geoengineering, and it's highly controversial.
All right, yeah, that's controversial, all right. In fact, some people think that's actually going on now, and there's actually a bill in the state of Rhode Island in the General Assembly. It's House Bill 7578, where it's what is this called? Relating to health and safety geoengineering, and then they go into a bunch of definitions and things that they're concerned about. You know, it just, how come every time Bill Gates is like involved with something, it seems to be really strange and, I don't know, questionable, let's say, at best.
How long will it be that countries keep experiencing these climate impacts before someone gets desperate and says, hey, we need to cool the planet with solar geoengineering?
It would look
I didn't say
like
it, he
this.
did it.
Thousands of planes would fly very high and use nozzles to inject millions of tons of light-reflecting particles into the stratosphere.
But pretend that doesn't exist.
It would create a thin chemical cloud of those particles around the whole planet, blocking some sunlight from reaching the surface. It would mimic a giant
Yeah.
volcanic eruption, which we know cools the Earth.
Yeah. And creates a disaster that looked like that. There was actually a volcanic eruption in 536 AD. And the effects of it lasted for 18 months. And it rendered crops useless. It just wiped out so many people. It was disastrous. I mean, they're literally like acting like it's a good thing to mimic this crisis. They weren't even, people had to resort back to hunting. There was no more planting. Crops didn't even work anymore. Everything went dormant. It's a crazy idea, to say the least. All right. There was another great idea that somebody else had.
This idea, crazy as it is, and it is crazy, in theory, it could work. It is a lot of fun to try to imagine how you might build a giant 1,000-kilometer plus bubble wall. I doubt we'll ever see it.
All right, bubble boy.
The team says the bubble shield could be in place by the end of the century and is fully retractable, which would combat creating even more space junk.
You can burst the bubbles.
However, there are concerns about the impact of shading on the Earth.
We don't know what happens when you reduce the amount of sunlight hitting the Earth. It's such a complex system. We can't even get the
Yes, we
weather
do.
right in Melbourne. How are we
Yes,
gonna
we do.
get the global
No, we know.
forecast to that level understood. It's an experiment that you only get to run once.
If the bubble shield works, I personally am psyched
Yeah,
that my
that's it. I'm not gonna go
great-great-grandchildren
any
could get the
further.
chance to
He's
burn
right. You
fossil
run it
fuels
once,
and treat
but
the world
yeah,
like
it's a
garbage
crazy
once
idea.
again.
This is being projected as a joke, but this was actually a serious idea. It came out of the World Economic Forum. They were basically saying, oh yeah, we'll put up these space balloons and block out the sun. Well, good luck using your solar panels with no sun. I mean, come on, man. And then you get to this other part of it, and you look at the Bill Gates, again, he's in the picture, pairing with Monsanto to have indoor farming. So he's involved with creating a problem of basically like a volcanic winter for who knows how long, because they can just continue to spray this stuff, and who knows how long that would last, right? And he's got an indoor vertical farming all set up and ready to go. This is not environmental, by the way. You can get the sun for free right now. It's just out there. You're actually absorbing energy. It's perfect. But he's going to have batteries and lights and pumps to run water and fertilizer. And that is not environmentally as sound as just doing it naturally, organically outside. This is really cool. This guy is just very good. Check him out.
Now I want you to notice on my slides that I have the ICA and the Heartland group, but you must understand I do not represent these groups. I'm speaking on my own. I have these symbols as a courtesy to the people who are organizing. But if you want to throw snowballs, you have to throw them at me.
I would actually highly recommend watching the entire thing. The whole thing's 24 minutes. I just took a couple of segments out. But
I'm also going to be talking about the flaw in some of the sea level rise projections that are currently done by satellite. There are two different measures, satellites, tide gauges. They are different. I'm going to explain why they are different, how they are different, and how they can be reconciled. I'm going to talk about some strange things, strange predictions, and you're going to see two of them right here. You see the current IPCC projection says we're going to have 1 meter of sea level rise by 2100. The current American National Climate Assessment says, okay, we're going to have 8 feet, which is almost 2 meters, okay? And it is
so dramatic in America.
Calculated on the amount of CO2 that humans produce and the amount that we are able to reduce, okay? And you see these 3 paths, and they're crazier here. I mean, this is absolutely ludicrous, and you'll see why in a few minutes. But again, the lowest figures that they show here and here are based on almost no emissions whatsoever. That means you're going to have to close all the factories, stop all the cars, figure out how to launch spacecraft with wind and electric. I need help on that because I work with my friends at NASA, and we have to send these things in the air.
Yeah,
And also, how do you
shit.
fly airplanes? Let me see if I can get these slides to move properly. This is the latest national climate assessment in the United States, not quite the 2018, but 2014. And again, you see 6.6 feet, which is even higher than the IPCC. They're trying to, there's 2 meters basically instead of 1 meter. They're trying to outdo the IPCC. And again, the bottom one is terrible draconian reductions in use of CO2. And again, you see, it starts in 1992 and goes up here, and depending on how much CO2 is there. And that arrow is the reality. We are not even halfway to the total elimination of CO2, and the sea levels haven't gotten there.
Yeah, that's always the case. That's what I've been saying. It's not taking the effect. Like, they built these models, and we're still not seeing it. So this is, I think, 4 years old. I think you said it was from 2018. It's gone even further. The models are even more wrong because they were showing this exponential increase. It's wrong.
Next, we're going to be seeing
They'll correct it
James
this way.
Hansen. James Hansen said around 2000 we're going to be getting 5 or 6 meters by the end of the century. And he makes this graph. Well, he found out pretty soon it wasn't working too well, so then he decided I'm going to change it. And now he says, well, it's going to be exponential. And that way, he still can't be proven wrong at this stage. Professor Murner decided he was
And they're
going
allowed to do that.
take the maximum possible. That
Man,
is
nobody's that flexible with
physically
me.
possible to do. And he comes up with 10 meters a year. However, he and I both agree, you notice there's a little red dot in the bottom here? Okay, if you can't see it, this shows it a little bit better with a little red arrow. That's where the sea level really, really will be.
It's a crazy difference in opinion, right? But at least he's showing some science behind it. Everybody else just comes out and they're like, oh, well, carbon's going up, so that must mean that the temperatures are going to rise and the sea level's going to rise, and there's going to be all kinds of problems. But this link. This is what led me into this whole thing. I was not thinking I was going to wind up on a carbon thing, but it seems like it's been the driving factor of the rhetoric, but it doesn't hold up when you look at the data. So anyway, he's got like some more stuff going on here.
We're supposed to get 5 meters in 81 years, right here. How's that going to happen? It's physically impossible, as Professor Murner showed before. Here's how we really measure coastal sea level. You do tide gauges. They are tied to the bedrock. They have a float inside. But tide gauges, if you average them all, there's a bias to them. Why? Because people put tide gauges where they're worried about the sea level rising. So Holland has many, many tide gauges because they see sea level rising. It's really Holland is sinking. Here on the west coast, we have Alaska. It's the same situation as Norway. You had the weight of glaciers. And in Alaska, they think sea level is falling, right? It's not. The west coast United States, you have the subduction of the Pacific plate. And that's pulling down the west coast. So Alaska is rising. They think sea level's falling. The west coast is falling. I think sea level is rising. Right in the middle, at the arrow, you have, again, the isotech of 0. This one happens to be in Canada.
Yeah, so that's a great point. Where is it possible that the sea level is relatively constant? You have air pressure that affects how it behaves, pushes it down. High air pressure will push it down. Low air pressure will release it. We got the actual movement of the earth and the terrain that the water goes over. It creates these differences in the height. But maybe it's really the land that's changing. Because we know that tectonic plates are moving. We know the continents have been kind of spreading around. We know stuff is moving. We know this. He's saying it like, this is rising, this is falling, and you can see it with relative to the sea level, because right in the center, it was 0. So is it possible that all of this, the whole thing, is just our perception because we live on land? We're not considering that we're changing. It's not actually the water that's changing very much.
Here the graphic shows sea level accelerating. No, not really. Seward had an earthquake. In the earthquake, Seward, Alaska dropped, fast, 64. But the trend in sea level hasn't changed. The trend was going slightly down before the earthquake. The trend is still going slightly down. So the graphic here, which shows a rise, is absolutely incorrect. This is a bad trend line. Don't follow it. What you need to do is look at the trend lines that are before and after. That's the real trend in Seward, Alaska, even though they had a massive earthquake. So this is the real trend. I just took the second section, this section here, and you see the real trend is a falling of sea level of around 2.6 millimeters. Why? Because Alaska is rising.
And there's a rise in CO2. Which actually brings me to something interesting, which is this. Hold on. What is that? This graphic here. This is from his presentation. I just pulled it as a screen grab because I didn't want to, spend too much time on it. But you can see that CO2 is cyclical based on basically what the trees and vegetation is doing, right? So in the earlier months before the summer and in the winter, you're going to have more CO2 because plants are not absorbing it, trees are not absorbing it, everything's kind of dormant. And then the flowers start to come in, absorb it, trees wake up, everybody comes back to life, and then it dips back down. So this is cyclical. So I guess it depends on when they actually take the measurement of CO2, because you could literally take the lowest point and accidentally measure at different times along the axis here and see a huge increase over time if you did that, say, once a year at a slightly different part of the year.
In the fact that they show a decline in 2010, 2011, where there was a huge typhoons coming up on Australia, sucking water out of the oceans, leaving it on Australia, and it basically replenished the Australian aquifer. It didn't fall on the land and go back in the ocean. So you had a sea level drop that was recorded all over the world. So we know the satellites are accurate. The theory here is that when you have a large ice sheet on, let's say, Greenland or Antarctica, the gravitational attraction of that large ice sheet pulls the ocean toward the ice and lowers sea level everywhere else, see? And when the ice melts, the sea level drops near here and rises everywhere else. It's a very, very subtle. And this is the adjustment that they try to put in the sea level numbers from the satellites. What they fail to realize, but accurately show in these diagrams, is that the massive ice on the land, when it enters the ocean, when it melts and enters the ocean, the weight of that ice pushes down on the seabed floor. And you notice the diagram here shows empty. The fact is this space gets filled with water, folks. It doesn't stay empty, right? The ocean floor is pressed down, and the second actually shows what happens. Here you see the seabed being depressed, and you notice here the sea level actually drops. So the GIA actually needs to be subtracted from the sea level that's reported by the satellites.
It's been fun doing a little zombie ice exploration here. I kind of got off track a little bit on this one, but you know, the idea that, you know, the sun, which is our, you know, greatest resource, it does everything for us. It grows our plants. It gives us our nutrition in our own bodies. It allows us to see, which is nice. But people are trying to classify it as a bad thing, and this is dangerous. So.